So what is epigenetics? It's a kind of a new buzzword out there. You may have heard it, you may have not. But epigenetics simply means we're looking at how our genes are turned on and off. So it's about changes to gene function that don't involve changes to your actual DNA sequence. So the DNA, those 23 strands of chromosomes and all of the structure of that, that's all the same, but it's about how is that being expressed? How are things turning on and off? So I love to use this little explanation that comes from one of my mentors, because this is a topic that sometimes can feel a little sciencey and a little overwhelming. So if you think about it, all of the DNA and all of the cells of our body is the same. Every single cell of your body has the same 23 chromosomes. But how does each cell know which part of the DNA, or we're going to use the analogy here of a recipe, that it needs? So how do bone cells know that they only need the part of the 23 chromosomes that relate to bone function, and muscles know that they only need that part that relates to muscles, and your liver only needs the part that relates to the liver? So epigenetic markers are sort of like this tape that masks off the parts of the cell or the recipe that are not needed by that type of the cell. So for example, bone cells can only see the part of the recipe and use that part of the recipe for bone cells, not for muscles, not for the nerves, not for the organs, not for your hair, not for whatever else is out there. It's only seeing that part of the code that relates to that specific cell type. So hopefully that makes a little bit more sense of like, what does this mean? But the problem is, what does this have to do with illness? Sometimes markers get added in places that they aren't needed. So it blocks off the recipe an area needs. The muscle cell can't get part of the recipe for muscles, and it needs that in order to function. Sometimes markers can fall off in places where they are needed, and that means we unlock a part of the recipe not needed for that area. So then all of a sudden that same muscle cell starts seeing something related to bones, and it gets a little confusing, and maybe it starts doing something it's not really designed to be doing. And then sometimes things happen to cause too much or not enough of a recipe to bake. And so what we call that in science is transcription. It's like the copying of that particular part of the code. So that relates to things like the growth of tumor cells. Too much of a recipe for that cell type starts baking, and it's like it just keeps going, bake, 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 more, 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 more. And there can be an overgrowth of things. Or it could be not baking at all, or copying at all. So why did these changes, epigenetic changes, happen? What causes markers to go on places where they don't belong, fall off where they don't? So we're going to talk about a bunch of different factors. The first is exposure to toxins. The second is trauma, or things like PTSD, and that can create changes in the epigenetic landscape. Stress is a big cause of epigenetic changes. The toxins that your ancestors were exposed to actually affect you. So if your ancestors have a change in terms of what part of the recipe is available, many times your body will inherit that same change. Traumas that your ancestor were exposed to, same kind of thing. In that case, a lot of times it's like we're trying to adapt to something. You know, it's like that got passed down to try and save you from dealing with this particular circumstance that your grandmother or your great-grandmother or your grandfather or great-grandfather had to deal with. But you're not dealing with that circumstance most of the time, and so it's really not helpful to you. And then diet, we can have epigenetic changes due to diet, and those can either be actually beneficial, we can help shift the code in a positive way, or in the negative sense, they can cause detriment to the epigenetic landscape. And then exercise, again, or lack thereof. So what does this mean for you? You've just heard a bunch of different sciencey things, and now it's like maybe saying, well, what does that mean? Why do I need to know this? So the good news is that we have more control over disease than we once believed. So there was that old paradigm that most diseases were caused by our genes, and our genes were our destiny, hence the name of this webinar. And that meant we had little control over health or illness. You know, we thought that we had good genes sometimes, like we had a healthy family and ancestry, or we had bad genes, and so we were doomed to have that same sense of, or same diseases that our ancestors did. So with an understanding of epigenetics now, with the new science that's come out, it's believed that only 3 to 5% of all disease is genetic. That's a very small percentage. So that's really actually great news, because it's much harder to change things at the level of the DNA and the genetic code. Epigenetic things are easier to influence.